Hello class, welcome back. I would like to continue with chapter 2, section 2.3, 2.4, 2.5 today. And let me share my screen with you. This section very short, so no rust. So let me open up chapter 2.3. All right. So chapter 2, section 2.3, you will learn about visualizing variation in categorical variables. So 2.1 and 2.2, you learn visualizing variation and all kind of the shape for numerical variables. So this time we're focusing on categorical variables. And the graph that represent for categorical variables are bar charts and pie graph. Okay, so look at here. So for bar chart, you already know how it look like. It's very similar to histogram or Pearson chart, which is in the e-text if you want to read more. And record data categories along the horizontal axis with the height corresponding to the frequency of the data. Okay, so let me show you how it look like. Here is the example. Here they're talking about the students interested in UCLA statistic class. And we are having the class below. Unknown, we have 7 students. First year student, you have 0. Sophomore, we have 3. Junior, we have 4. Senior, we have 5. And graduate, we have 1 in the class. So let's say the total is 20 students in a statistic class. And in order to graph this categorical variables here, you can graph whatever you want. However, we would like to choose to graph from graduate and then junior, senior. You see that they did not, so it's not matter. So it's okay to graph any pattern you want. You can grab a known first, and then for first year student, it looks like you got 0. You don't have to grab that. Okay, so unknown got 7. You can grab that first in here. So, but here they grab the last. And sophomore got 3, and then you go all the way to 3. But look at here for this type of bar graph, they already convert all of this in percentage. You don't have to. So you got 2 ways. You can write just the number here. That's totally fine. So right here, they did a bit more like for us to see percentage. It's because some question may asking for percentage. Then you can see right away right here. Relative frequency will be percent right here. So 0.35 represent for 35% of the unknown student take the stat class. And right here, this column represent for about 15% of the student of the whole class. They are sophomore taking statistic class, and so on. And for bar chart and histogram are different. The differences you can see for bar chart are the rectangle have to be construct apart. And for histogram, they might be apart, but most of the time, the bits have to be consecutive. They have to connect to each other. The key differences, histogram may touch. You see that? May touch. Sometimes it's not touch. Corresponds to bit width and numerical order. And for bar chart, they do not touch. Can be any design width, yes, but need to be all the same size. And no inherent order. Doesn't have to be in order. And another chart, kind of similar to bar chart, is Pareto chart. Pareto chart is a bar graph, but these bars are arranged from tallest to shortest. Okay, so make sure you understand these key terms right there. So this cannot necessarily be done in a histogram. Yes. You can look at the Pareto chart in the textbook, or you can Google it. For pie chart is a circle graph, and it's a circle divided into pieces, and the area of each piece is proportional to the relative frequency. The word relative frequency is mean the percentage, okay? And you have learned already the percent can be a decimal number. So they convert back and forth. They are just the same value, or percent of the data in that piece. So here is a sample about pie chart. Here, the same thing, right? Categorical. We have graduated this color and known this color. But for me, I prefer you should write percentage in each box, okay? Because look like this, yeah, you know this would be a lot more percentage, but you do not know how much large. But personally, I would like you to put percentage in here too. All right, so I'm finished this section. And previously, I keep saying that I will run StatQuant. I meant I will run StatQuant in separate video, like for most of the section, for you to see one time, okay? Because I don't want to interrupt my lecture. So I will record a video separately, only StatQuant that I can run for you to see everything. Thank you, everyone. And let's move on to section 2.4. Let me go back and double check if I share my screen already. Let's see, did I share my screen? Okay. I believe so. All right, so let's move on. 2.4, what do you learn in 2.4? So 2.4, you were learning about summarizing categorical distribution. Okay, so it look like you need to learn a kind of variability, like numerical distribution in 2.1 and 2.2. But this one, you learn a bit about mode. Okay, how you can identify mode. Actually, in numerical categorical, you can identify mode too. But it looks like this textbook didn't mention anything about mode in numerical data. But that's fine, we follow this textbook, so you don't have to worry about it. And you will learn how to describing categorical distribution. You learn the shape, the center, the variability too, all right? So describing a categorical distribution. So let's recall, to describe a numerical distribution, we record the shape, center, and the spread. So since categorical data has no inherent order, so this measure do not make sense for the categorical data. So actually they are using kind of a bit the same for me, but they're using different word. So right here, for the I kind of I forgot. I thought there would be the section about this. I believe it would be the next section. They're talking about kind of similar to shape, center, and spread, but they're not mentioned here. They're most focusing on a mode here and variability. No worry. I'm sorry for any confusion. Any confusing? So two main components of a categorical distribution is mode. Mode is mean the most data repeated or the most frequent, okay? That's what it means. So like a lot of data focusing on that value. So we call that value is mode. Variability similar. So right here is it's a diversity in outcomes. So diversity in outcome here is saying that we have variety of outcomes. Okay, so let me jump to the example. Hopefully it can make more sense to you. So mode is the category that occurs the most frequently. Okay, so key difference in the mode for categorical and numerical data. So let's see, we compare. For numerical data, mounts do not need to be the same height. So it's not like they talked about numerical data modes, but they did not include in the section numerical data. And I'm sorry for that. But here, you can imagine so right here it said mounts, which is the top. When you graph the data on the top, do not need to be the same height, which is for numerical data, if like we can have many modes. That's what it means. For numerical data, whatever the data repeat most frequently, maybe they don't give you specific number, like how many times they repeat it to consider a mode, but usually maybe 2 times and above, okay, will be considered mode. Then that's for numerical data. You can have 2 or more modes or 1 or more modes. For categorical data, the modes must be roughly the same height, which is they count only 1 mode. So we are the same height. So if they have 2 modes, if you imagine about bimodal, okay, bimodal, which is 2 mounts, the 2 mounts they having the same height. So it means both of that value will be called modes. All right. We use the same wording as before. Unimodal, 1 distinct mode. Bimodal, 2 modes with same or very close frequency. Multimodal, more than 2 modes with or close frequency. Actually, I'm not really testing you on this, so here for you to know, I do not want you to get confusing. So mode example, this picture. Look at this picture. So this is look like bar graph. We're talking about categorical data. And categorical data is they talking about the most frequently height, right? So compared to this 4 rectangle, the most highest is this middle. So this middle would be called a mode in this categorical data. But if in the numerical data, the mode might be this one, this column, and this column, total 3 value. Okay, so just let you know the differences. The variability. The variability, think of this as diversity in the data value. So what do we look for? High variations, each value is represented with about the same frequency. Okay, so many observation in many different categories. So low variation is, so this, remember this, we're talking about categorical data only. Look at the low variation. A small number of value appear a large number of times. Many of observation falls into a few categories. Caution. So variability here is more about the occurrence of many different values rather than many frequencies. So let's look at the example. There's 2. We have 2 bar charts here. Look like school A, we got many rectangle, but school B, we only have 1, 2. But look like they are focusing on Hispanic more. So compared to this one and this one, you can tell school A has greater variability in ethnicity and compared to school B. That's what it means. All right, I'm finished section 2.4, and I hope you understand a bit about categorical data. and how to look at and tell the variability in categorical data. And now I would like to jump right away to section 2.5, which is the last section in chapter 2. In chapter 2, this section you learn about interpreting graph. Okay, making appropriate graphs and misleading graphs. So we're comparing. Actually, for this one, you already learned in 2.1 to 2.5 already. This section, it looks like summarizing what we have learned. For numerical data, we're using dot plot, histogram, and stem plot. And for categorical data, we're using pie chart and bar graph. You already, in your head, visualize how this graph look like, right? For numerical data, the shape, we analyze the shape, analyze center, we find center, and the spread. Actually, they can be the same meaning. Variability right here is okay. And for categorical data, we look at for the mode. And you know the mode already is the highest frequency. If they have two maps, then they have to be the same height to consider they are mode. And variability is like spread out or less. For numerical data, actually there's a bit specific about this is you need to compute S. Let me annotate on this. You need to compute, we call standard deviation, S. For this S, you can compute by hand by using formula for next section in chapter 3, or you can run by StatQuant. They give it to you right away, or TI-84. All right, class, I'm finished. If I make any mistakes, please let me know, and please support me, like give me feedback or comments so that I can improve myself. I hope you enjoying this chapter and enjoy the class. Hopefully I can make you understand that better a bit. And please teach me too if you know anything new, and you can share with me in my office hour. Thank you and have a good day. So we have finished chapter 2 and see you in chapter 3.